Good morning, everyone. Today we are covering Unit 1, Lesson 7, solving equations of the form x to the power of n equals a. So x to the power of n equals a can be solved a couple ways. We can use trial and error, or we could take the nth root. All right, so these are the ways we're going to look at today for solving these equations. Or we could take the nth root. So if n is even, then you will get two solutions. If n is odd, then you will get one solution. I'll show you what I mean by that. So if we had the equation x to the power of 3, our n value is odd, right? 3 is our n value, so we have an odd n. If we were to create a table of values, so let's look at a table of values for -3 to +3. So if we sub these values into our equation, x cubed equals 27, a -3 to the power of 3 is going to be a -27. -2 to the power of 3 is going to be a -8. And we'll just plug in the rest of our values here. Okay, so if we were to plot those values on our graph, we would have -3 and -27, which would be all the way down here somewhere, -2 and -8, -1 and 1, -1, 0, 0, 1, 1, 2, 8, and 3, and 27, somewhere up here. So we'll connect the dots. Something like this on this side, and like this on this side. Just erase this line we have. Okay, so the graph we just created is if we were to say y equals x to the power of 3, right? We have lots of different values for when we substitute it into our x and then our y values. So if we wanted to graph the equation y equals 27, so that would just be a horizontal line that cross at 27, y equals 27, then we can see the point of intersection where those two lines cross is our solution. The solution is 327. We can see they only cross at one point, so that confirms that idea that when you have an exponent of odd nature, then you're only going to have one solution. Only one number is going to satisfy that. But let's look at a table of values for x squared, which again, you know the solutions to these without having to do all this. We're just using it as an example. So we'll again do a table of values from -3 to +3. So a -3 squared is going to be a +9. -2 squared is 4. -1 squared is 1. And then the positive versions will be the same numbers. So this table of values is again that y equals x squared equation. So if we graph it, we should have a graph. Looks something like this. This is going to be y equals x squared. Well, if we graph y equals 4 on this graph, we can see that these two graphs actually cross at 2 points. So we're going to have two solutions. Just like our note said that if you have an equation with an even exponent, you're going to have two solutions. So solutions here are plus or minus 2, and your y value is 4. So they cross at plus or minus 2, showing that, again, they have two solutions. So let's look at this in a different way. So we could also take the nth root, which isolates the variable. So we take the nth root, we're isolating the variable, we're using algebra to solve the equation. So looking at x to the power of 3 again, if we want to isolate this variable, so we want to get x all by itself, we need to somehow get rid of that power of 3. We need to make it a power of 1. So in order to make that a power of 1, we should recall that if we take 3 and times it by its reciprocal, or times it by 1/3, that will equal 1. So that's what we're going to do with this equation. We're going to take x to the power of 3, and we're going to multiply that exponent by 1/3. We're going to need to make sure we do that on the same side, or on the other side of the equation. So when we take a fractional exponent, it's the same as taking the third root. So x to the power of 3 raised to the power of 1/3, well, 3 times 1/3 is just 1. So that'll simplify to just x. And 27 to the power of 1/3 is the same thing as taking our third root of 27, which will equal 3. So let's look at doing the same thing with x squared. So we could take x squared and we could raise it to a power of 1/2, because if we multiply, right, by that reciprocal, it'll reduce to 1. And we have to do the same thing over here with our 4. Raise it to a 1/2 power. So this will just simplify to x, and this will be the second, or square root of 4. And if we take the square root of 4, we can see on that graph we did on the previous slide that the solution will be a plus or minus 2. Okay, we're going to look at having an exponent for that's a fraction, but a little bit different, where our numerator of our exponent is something other than 1. So when we have 27 to the power of 4/3, the top number represents your power, and the bottom number represents your root. So we would say that 3 is our root, so that goes in there, and the 4 is our power, so it's being raised to a power of 4 first, and then obviously the number under the radical is what we're evaluating here. So we'll take the root of 27/3 first. We'll deal with the bracketed part first. So the third root of 27 is 3, and then we're going to raise that to a power of 4. 3 to the power of 4 is 81. So we'll look at that over here as well. So that 4, once again, that's going to be our root, and 1 is going to be our power. Well, when we have a power of 1, we know that doesn't change it at all. So we could say the fourth root of 81 raised to a power of 1. So the fourth root of 81, remember that is if we were to do that on our calculator, we're going to get 3. So the fourth root of 81 is 3. So we're going to look at these now with some exponents and see if we can solve them. So determine the real roots of x to the power of 3. So if we have x to the power of 3 equals 9, again, we need to isolate x. So we're going to raise that to another exponent of 1/3, and we'll do the same with our 9. So that'll become just x, and this will become the cube root of 9, which if you were to type in x to the power of 1/3 on your calculator, you should get 2.08. Okay, over here we have x squared equals 18. So x squared equals 18, which means we're just going to take the square root of both sides. Right? When we don't have anything in our radical, we know we're just talking about the square root. So we will have x equal to, we should get 4.24, but remember that this is an exponent that's even. So we should have two solutions. So 4.24 is going to become plus or minus 4.24 because it was an exponent that was even. Okay, so that's all for today.